Biological agents have evolved the unique ability to influence the thoughts, moods, and personality traits of their hosts. These microscopic organisms interface directly with the mammalian brain to alter the behavior of the creatures they inhabit. This research is grounded in peer-reviewed laboratory science. For decades, biologists have documented the chemical and physical pathways these organisms use to achieve this level of control. These organisms occupy the host's nervous system, rewriting baseline behaviors to facilitate their own survival and reproduction. The Ophiocordyceps fungus begins its life cycle when a single microscopic spore lands on a foraging ant. The infection is initially silent, allowing the ant to return to its colony unaware. This X-ray cross-section shows the mechanism. Orange roots wrap around limb muscle fibers, leaving the brain untouched, to drive the ant manually. It forces the ant 25 centimeters up a stem, locking its jaws onto a leaf. With the host in place, a fungal stalk bursts through the ant's head, releasing spores onto the trails below to infect the next generation. Fossilized leaves indicate that this specific parasitic strategy has been functioning successfully for 48 million years. The ant's autonomy is replaced by an ancient biological script. In aquatic ecosystems, the parasite Euhaplorchus californiensis targets the central nervous system of the California killifish. Infected fish abandon their natural instinct to hide. Instead, they swim to the surface and perform a shimmying motion, flashing their reflective bellies toward the sky. This behavior is a calculated risk for the parasite. It must reach the gut of a bird to reproduce, and this chart shows the result. Infected fish are 30 times more likely to be eaten by a predator than their healthy peers. A similar reversal occurs in freshwater shrimp. When infected by certain parasites, these light-averse creatures suddenly seek out the surface, positioning themselves to be consumed by ducks. Core survival instincts are effectively inverted, turning the host into a transport vehicle for the parasite's next life stage. This raises the question of how a microscopic organism without a brain of its own can rewrite the signals of a complex nervous system. One method is chemical manipulation. Parasites produce compounds that mimic the host's natural neurotransmitters, sending false signals through existing neural pathways. Others use direct neural invasion, physically growing into brain tissue to latch onto nerve clusters and manually alter electrical firing patterns. There is also immune exploitation, where parasites hack the connection between the gut and the brain to influence chemistry from a distance. These methods demonstrate that complex nervous systems are vulnerable to invasive biological code. Studying these threats requires massive electron microscopes, particularly for Toxoplasma gondii, a single-cell parasite that has mastered the mammalian brain. Toxoplasma must move from the body of a rat into the digestive tract of a cat to complete its life cycle. To bridge this gap, the parasite performs a surgical strike on the rat's fear center, neutralizing the innate terror of predators. The rat becomes actively attracted to the scent of cat urine, causing it to walk directly toward the predator it would normally flee. Even the most deeply ingrained survival mechanisms can be deactivated by a single-celled organism. An estimated 1/3 of the global human population currently hosts dormant cysts of Toxoplasma. Transmission is often tied to the mundane reality of our food supply, primarily through the consumption of undercooked meat. The second common vector is the domestic cat. Living in close proximity to felines and their litter boxes creates a direct path for human infection. While long considered harmless in healthy humans, studies have linked the infection to subtle behavioral shifts, including slower reaction times and increased entrepreneurial risk-taking. Some data suggests gendered anomalies, with infected men showing increased suspicion and infected women displaying higher levels of extroversion. On a macro level, researchers have found a positive correlation between national infection rates and societal neuroticism scores. These correlations do not prove causation, and dormant cysts are generally considered benign for those with healthy immune systems. The existence of these mechanisms suggests that our personality traits and daily choices may be the downstream results of an ancient biological war. For more deep dives into the science of the unknown, hit the subscribe button. We'll see you in the next one.